Hello fellow lemons, welcome to another Mix It Up Monday tutorial. I'm Griffpatch and today we are going to start a little project based loosely around the classic game Asteroids. But, well, far more over the top. As you can see, lemons have achieved interstellar capability and are attempting to take over the universe. To tackle such a scenario, we obviously need to fight back with rapid-fire lemon-bursting lasers. So, what's the coolest thing we're going to learn while making this game? That would be how to handle loads of rapidly moving projectile clones and enemies, and how to robustly handle the collisions between them. As a bonus, we'll also tack on some cool special effects including damage and explosion flashes, and the much sought after camera shake. Today we're going to cover the basic player design, movement and shooting of laser projectiles towards the mouse. I'm also interested to know how many times I can say the word lemon in one episode. Lemon, lemon, lemon. Were you counting? Okay, let's get scratching. We'll begin with the player's spaceship sprite. I'll politely discard my pal Scratchcat and create a new sprite in its place. We'll need to draw a ship that faces to the right. That's the direction we almost always need to make our sprites face. I often forget and end up drawing it facing up. So, we can use a rectangle, holding the shift as we draw it to perfectly keep it as a square. Then, switching to the shape tool, select one corner node and click delete to make a perfect triangle. Now, using the selection tool again, I can rotate the triangle, but again holding the shift key while dragging it so as to rotate by exactly 45 degrees. Okay, next trick. Grab the top resize node and hold down the Alt as you drag down. This resizes the object around the middle. Very useful. Next, I drag the triangle until it snaps to the centre of the canvas. It's important to do this so that the ship will rotate beautifully around its middle point. But then, once centred, I then drag it to the right a little bit, again while holding the shift key. This lets it move without it allowing to go up and down, so it stays snapped to the middle in the vertical. Okay, and there's more tricks yet. Hold down the Alt key again, and then left-click and drag the triangle to create a perfect duplicate. But while still dragging, hold down the Shift key, and pow, the shape is snapping to stay lined up with the previous shape. I'll colour it lemon yellow. This ship is already looking cool. I think I'll drop the border thickness down a touch. Right, I didn't name the sprite, so let's name it now, Player. Next, we can make the background nice and dark by switching to the stage. I'll convert it to a bitmap and fill the entire screen with a colour that's almost, but not quite, black. Okay, back to the player sprite, and let's fill in some code. It's going to be a basic game loop this time. We'll set it up with a when green flag clicked. Bring the player to the front of all the other sprites, and go to the centre of the screen. We'll want our ship to have smooth movement, so we'll keep track of its momentum, that is its speed. Make two new variables named speedx for this sprite only, and speedy, also for this sprite only. And we'll be very good and set them both to 0 before the game gets going. Always good to reset your variables like this at the start of the game. Now for the game loop. Bring in a forever loop. So what shall we do first? How about left and right movement? We can do this in so many ways, but the pattern is always very similar. I'm going to make a new custom block, naming it MoveX, and adding in a numeric input of joystick X. Now people ask, why do I use so many of these custom blocks? The truth is, we don't always need to, but one huge advantage is that they break up your code into nice chunks, and they give each chunk a rather nice name. That can be a lifesaver when you come back to a project later and want to find something. It's just so much more readable. We'll use the MoveX block right away, and I'm going to use the same key press trick we did in some other tutorials of putting the key press blocks inside a subtract operator, like this. Either we can have right arrow pressed, subtract left arrow pressed, or, as I'm going to do now, key D pressed, subtract key A pressed. That's the WASD keys. This beautiful little trick gives us a -1 for left, a 0 for no movement, and a 1 for right. That's really useful. Okay, so the joystick X input here will now, as we just said, be -1 for left or 1 for right. Let's use this to change the player's speed X variable, specifically by 0.9 multiplied by joystick X. Now the 0.9 here is the player's acceleration. Feel free to create a variable to hold the value if you prefer, but I'm just being quick today. Next up, we set speed X, not change this time, set speed X to 0.9 multiplied by speed X. This is not the same 0.9 as the one above. This one is for air resistance, to slow the player back down. With the speed variable now updated, we can change X by the speed X to get the player moving on the stage. Let's give it a quick test. Run the project and press the left and right keys, whichever you assigned. There, that's a nice feel. Cool. We can do the same now for up and down. Make a new custom block, move Y, with an input of joystick Y. This code will be just the same as for the left and right. Change speed Y by 0.9 multiplied by joystick Y, and set speed Y to 0.9 times by speed Y. And finally, change Y by speed Y. We can pop the new move Y block into the forever loop and pass in the key W, or up, subtract key S, or down. Let's test that again to check we have full movement now. Yeah, beautiful. All we need now is to rotate to point towards the mouse cursor. This is going to be quite a fast-paced game, so I'm not going to limit the speed of turning. So it's really easy. Just drop in a point towards mouse pointer and we're done. Yeah, I like that a lot. Now we are facing the right direction. We need to be able to fire those lemon-bursting lasers. Make a new sprite, naming it Laser. We can start by zooming in and drawing a long rectangle, remembering to snap it to the centre of the canvas again. I think a fill colour of white, but with a lemon-yellow outline looks neat. Next, I'll round the ends of the laser beam with the Shape tool. Just click to create new nodes on the top, bottom and mid-right edges like this. Now we can click on the corner nodes and press the Delete key to remove them, leaving a not half bad rounded end. Do the same for the left end. To finish it off, I'm making the border a bit thicker, size 2, and now to ensure the laser is correctly drawn, I'm going to draw a completely transparent rectangle around the entire shape. This is not crucial, but it helps to ensure the laser's edges are nice and crisp and don't get cut off weirdly. I'm sure the scratch bug will get fixed one day. Okay, let's put some scripts together, beginning with the initializing scripts. When green flag clicked, hide. The laser only wants to be visible when cloned. The original sprite should be hidden, and in fact will never be used as a laser sprite at all. This is common practice in Scratch. In fact, if you do try to use the main sprite, you can get into trouble because unlike all the clone sprites, the delete clone will not work on the main sprite. That can lead to bugs, where one bullet suddenly appears on the screen and won't disappear like the others. So yeah, hide the main laser sprite. We're going to hang all our game loops off a when I start as clone hat block. This is very convenient for less complex games like this one. As soon as the laser is cloned, position it at the player's sprite location. We are going to want to send it flying out in the direction the player is facing. To match the player's direction, we use a point in direction block. Yeah, don't use the point towards player. That won't work. We could have used the point towards mouse. That would surely work, as we are at present always facing towards the mouse, but that may not be the case in the future. So, point in direction, and then find the of block in the sensing category, and switch the sprite name to be player. Now, you can select the direction of player. Neat. Okay, we need to show the cloned laser sprite, and then we'll begin a repeat until loop, repeating until the laser is touching the edge of the stage. Within the repeat, drop in a move block. And I'll change it to be 11 steps. The bigger the number, the faster the laser will travel, so have a play with that. This loop will finish when we hit the edge of the stage, so then delete this clone to remove it from the game. That all sounds good. We just need a way to trigger the laser to fire. Now we may be tempted to use a when space key pressed hat block. Then we simply can create a clone of self. Now which of you knows why this is not such a great idea? Let's give it a test. I can press space, and a single laser fires out. On first inspection, this is working very nicely. So the cloning and laser movement scripts are great, but because I have Scratch add-ons installed, I can see how many clones are being used as I launch each laser. And look at that! How is it possible that I'm using all 300 clones at once, with so few lasers showing up on screen? Any ideas? Okay, let me explain. This is a super common bug for Scratchers who are new to using clones. Look back at where we added the create clone block. Here it is. Whenever the space key is pressed, we create a clone of ourselves. Seems harmless, until you consider that this is being triggered on the laser sprite. Now tell me, how many laser sprites are there at once? Well, there's one sprite to begin with, but as soon as I press the space, we clone the sprite, and then there are 2 laser sprites. So when I then press the space again to fire the next bullet, not just one laser sprite will trigger a space press script, but 2. And both sprites, the original and the clone, will both create new bullet clones of their own. Of course, because the clone creating script places the new bullets at the player, all these new bullets appear on top of each other, so we only see 1, even though there are 2. So that makes 4 bullet sprites, even though we've only pressed space twice. So now, can you guess what happens if I press space a third time? You guessed it. 4 bullets becomes 8 bullets, and then 16, 32, 64, 128, 256, and pow, we've exceeded the 300 clone limit. It doesn't take long before all the clones are used up. Disaster! Because we'll need to keep all these clones available for all those lemons. So, the mistake we made was to have a key pressed on a sprite that is being cloned. Always remember, if a sprite is cloned, that all the clones will be receiving the key press event. Okay, much easier to trigger the clone event from the player sprite instead. Make sure to delete this when space key pressed hat block. Click into the player sprite. We'll make a new custom block named shoot, and we'll use it right after pointing towards the mouse pointer, down here. Now I don't want to trigger off the when key pressed because I don't fancy the player having to mash the space key that much. Instead, I want a steady stream of lasers to fire out as soon as the key is held down. So add in an if space key pressed or mouse down. We might as well allow the mouse to fire too. And then we'll use the create clone of and switch it to clone the laser sprite. Great. Shall we give that another test? Mash the green flag. Oh man, yes, look at that. That's insane firepower. Lemons don't stand a chance against that. Yeah, so I think we need to rein that back in a touch. Limit the rate of fire. Make a new variable to keep track of this, naming it fire rate for this sprite only. We need an if-else block and check if the fire rate variable is larger than 0. Oh, move the key press check into the else side. We only want to allow firing of the laser when fire rate has decreased to 0. So yeah, if the fire rate is greater than 0, then change the fire rate by -1. Then, after creating a new laser, set fire rate to 10. This will now not allow the laser to fire again until it has decreased back down to 0. Let's give that a test. Oh gosh, that feels slow now, a regular pulse of just 3 laser blasts per second. That could work for early levels perhaps, but it's not going to be a match for the number of lemons I have in mind. No, I'm counting on there being quite a lot of lemons indeed. So, perhaps let's try setting fire rate to 1. Okay. That's nice. It's perhaps a little quick, but I kinda like it. It's a nice compromise, and I'm feeling it will give us perhaps some chance of warding off even a somewhat excitable lemon invasion. Right guys, this is the end of part 1 of this tutorial. If you want any game assets, then I've included a link to a Scratch project in the info under this video. I think you should take the time though to have fun and make the spaceship costumes yourself. But there's also some cool sound effects in there for you to grab, so have fun. The next episode will build on this tutorial, and we'll finally get those lemons into the game. Lots and lots of lemons. Yeah, and that is where the fun really will begin. But I hope you've enjoyed this video thus far. Please do smash the like button and don't forget to subscribe to the channel to avoid missing my next exciting video. Thank you so much to my new channel members. Joining the membership is a huge deal because, simply put, more supporters translate to me being able to make more videos. It's that simple. That's right, you can help make this channel awesome. Oh, and there are some fantastic perks up for grabs too, so check that out. And that's it. Thanks for watching, and scratch on, guys!